So let's take a look at this one here. F of x is equal to sine x. We want to do the arc length between 0 and pi over 2 on the graph of the sine function. So quick little zoom in here. Y equals sine x. We need to zoom in a lot here. And I'm looking at the interval between 0 and pi over 2. Of course, remember pi over 2 is that top peak of the first peak that the sine function comes to. So we're looking at the length here from 0 to this point here, pi over 2, 1. 0, pi over 2, 1. Okay, so that's what we're looking at here. So we could approximate it by looking at the straight line from 0, 0 to 1 pi over 2. Right? And we could approximate it by looking at the length of that line. If you look at this as a triangle, it's a pi over 2 base. It's a 1 length. So we could approximate that using the triangle here, a 1 length and a pi over 2 height. So if you did that on a regular calculator, we could approximate it as the square root of 1 squared plus pi over 2 squared. And that would give me an answer 1.86. Now I know that that's not right because this is not a straight line, it's a curve. But we could approximate it roughly as 1.86. And so I point that out because we're going to compute it exactly, or approximately, because we're actually going to have to use technology to do it. But our answer is going to be pretty close to that. Okay, so to do this, we need the derivative. F prime of x is the cosine of x. Is the cosine of x. Okay, so arc length would be the integral from our bottom point to our top point, 0 to pi over 2, of the square root of 1 plus f prime squared dx. And now we are hopeless to do this. We are hopeless to do this. You can do some rearranging of the cosine squared, or you can use that identity to rewrite that as 1 plus cosine 2x over 2. But really even that leaves you kind of like, ew, what do I do? So here we're just going to go straight to technology. So we're going to use our fn int. So let me pull up my calculator here. Again, fn int. I go to math, number 9, fn int. This is the integral from 0 to, now I've got to find my pi on this calculator. Looks like it's, where is pi on this calculator? Oh my goodness, I should have looked this up beforehand. I'm thinking it's here. Yeah, there's pi. Shift exponent on this calculator. Over 2. And then we're going to do the square root. So shift x, square root of 1 plus, and then I'm going to do the cosine of x squared. And let me just real quick make sure I'm in the right mode. I am in radian mode, so that's good. And so now we're ready to approximate this. Square root of 1 plus all that stuff. And so you can see we get an answer of 1.91009888945. I'm just going to approximate that as 1.91. 1.91. There may be some advanced integration techniques that would allow you to maybe evaluate this. I'm not aware of them right now. But for us, it's definitely beyond our scope to try to compute something like this by hand. So we are going to, at that point, rely on technology. So we use our technology here to compute that for us.